Alright, so last time we have come across what about the metal react with water, okay? Now, for metal react with water, okay, here shows they will form metal hydroxide and hydrogen. Okay, now, but we also need to notice that what kind of metal are used in this reaction. Only 3 of them: potassium, sodium, and calcium. Okay. Of course, if one day we can find some metal more reactive than potassium, they can be do so, right? But up to this moment, we got 3 only. Now, today we are going to discuss what about those metal which is less reactive than calcium, okay? For example, what about magnesium? Okay, well, magnesium is a reactive metal for sure, but they cannot react with water directly. So in order to start a reaction, we need to input more and more energy for starting the chemical reactions. Okay, with more energy, that means we need higher temperature. Well, in this high temperature, water will exist as steam instead of liquid water. Okay, so here we have write it down, steam, and the result will be metal oxide instead of hydroxide will be obtained, and again hydrogen is also obtained during the reaction. And here shows with higher temperature the reaction can start from potassium, which is in the top of the series, up to iron metal. Okay, and this is the range we need to notice. Okay, let me highlight it first. Yeah, this is our range. Okay, so back to our discussion. Now write it down again. From potassium to iron in the reactivity series, we can have a reaction with steam, and the work equation will be metal react with steam, which is H2O bracket G. Okay, bracket G for gaseous state to have metal oxide and hydrogen. Okay, now this equation is important again, but I think you sure enough. Okay, oxide is O2 minus iron. Okay, so you can make a chemical equation by yourself, but the problem is, well, how the reaction goes on, how what looks like the reaction set up. And here we got pictures. Okay, pictures here first. Now, so where the steam comes from is from the damped mineral rule. Well, sometimes they will use red sand instead. Well, red sand I think is no problem. But what is mineral rules? Okay, now rule is 羊毛. Okay, it is actually a fuel you can catch fire when burn the wood. But mineral wood is another story. They are actually, you can treat it as a very small, very fine stone, okay, or gas fiber, okay, because they are not the fuel, so they will not catch fire even in the high temperature. Okay, so feel free to hit it. Next one, of course, we got metal, no problem. But during the heating process, you can see, okay, our focus will be this way. The heating is under or beneath the metal instead of beneath the mineral wool, because the metal, okay, let's write down, metal should be hot enough to start the reaction. So if your Bunsen burner is placed under the mineral wool instead of the metal, okay, then the metal may not hot enough to start the reaction, and then the steam will just pass through the metal without anything formed. Okay, so make sure that. Well, next one is, okay, we have a delivery tube, and finally, well, how can we collect the gas bubble, the hydrogen? Well, we use a trough with water. Okay, well, that is simple. Now, but during the process, okay, the first tube of bubble obtained will be discarded. Okay, now after you start the Bunsen flame, the gas bubble start to form, but the first tube of gas bubble we obtained will be given up. We will not use it. The reason behind is because they are air in the tube. Okay, well, the tube with air inside, when you start heating, the gas will expand, okay, and pass through the delivery tube and then to the trough of water. They are not hydrogen at all, okay, that's why we need to give them up. Well, at the end of the reaction, you or we should remove the delivery tube first, because otherwise when you switch off the fire, the tube will cool down and create a low pressure system. Then the cold water will sucking back to the hot tube and then lead to cracking. Okay, so there will be a video showing to you, okay, and you will know how the reaction goes on. Okay, so the address of the YouTube video I will send you in WhatsApp afterward. Okay, now back to our discussion on the chemical equations. In case we use magnesium, okay, so here shows Mg, of course this is solid, and H2O gas will form, according to the work equation, metal oxide will form, that is MgO is solid for sure, and H2 gas. Okay, now the problem is, how come I know that the MgO is solid? Because from these pictures you can see, after the reaction, the metal still trapped inside the tube, right? The metal will not touch water anymore after the reaction, and that's why there will no aqueous solution form, because no water involved in the tube, right? Well, how about aluminium? Aluminium solid react with H2O gas will form aluminium oxide, Al2O3. Again, this is solid and H2 gas, right? Okay, let's balance it, okay? On the right hand side, we got free oxygen. Well, that means we need free water to balance the number of O in the reaction, right? And on the right hand side, we got 2 aluminium. Okay, good. We insert 2 here. And finally, on the left hand side, we have 6 hydrogen. So we need 6 hydrogen on the right hand side like this, and right? And this is our final chemical equations. Okay, so I think you can do it by yourself from using word equations. Okay, now there is the material we come across in last lessons. The next problem will be some addition informations. Okay, well, the first addition information is, some of you may wonder, well, how about if I insert potassium, sodium, and calcium into this setup? So will I obtain metal oxide or metal hydroxide instead? Okay, now if you insert potassium, sodium, and calcium into this system, okay, then you will obtain metal hydroxide. Okay, metal hydroxide. Now, the reason behind is very simple. Maybe you will ask, both steam and water are H2O, but how come they will form different products, right? Well, the answer is it depends on the stability of the compound formed under high temperature. Well, this is what we call thermostability. Will it decompose under high temperature easily? Well, for those magnesium, aluminum, zinc, and iron, we found that the metal hydroxide doesn't look good in high temperature. They will break down easily. Okay, in fact, in high temperature, metal oxide, or more precise, oxide iron will be more stable. Okay, that's why in high temperature they prefer form oxide instead of hydroxide. But how about the good one element and calcium? Well, because they are very reactive, that means they can form stabler compounds towards heating, and that's why they can keep their hydroxide even though in high temperature. Then the result will be they form metal hydroxide, okay, even react with steam, but only limited to this three choice. Okay, so this is what we taught in last lessons. So if there is any problem or any additional information you want to ask, so feel free to ask it. Okay.